is Malte, and I'm the CTO of Vercel. And today I want to talk about framework-defined infrastructure in quite some depth. But, if you haven't heard about Vercel, let's talk about that really quick. We are a front-end cloud, and it gives your teams the tools and the capabilities to develop, preview, and ship at the moment of inspiration. Now, that doesn't say too much. This is the picture that I like to give you folks to understand what we're doing, right? You're building a web app, you're throwing it over the fence, and we're serving it for you, right? Which is nice, right? So you don't have to carry a page necessarily, and we're also generally doing a really good job because it's our job. Awesome. And to make this a little bit more clear, if you're in a modern development environment, for example, using GitHub, and you're making pull requests, then we will come and we will take your pull request and deploy it on our platform and give you a dedicated preview URL to give you the ability to look at your changes. And we do it every single time you commit, you push, and then finally, when you're pushing to production, we're redeploying your site as well. Now, as we're doing that, and this is actually really important for this talk, is we are looking at your application, we're analyzing it. For example, here we have a Next.js application, and we're looking what's inside of the application, and then we're deploying it. For example, edge middleware, static acids, etc. Right? So I put the screen here because it's actually really important for this presentation. But let's skip over it really quick. Another thing we do is we make a framework called Next.js. It's the most popular React framework by far. Gets a whole bunch of downloads, and all the greatest brands on the web are using it. Cool. That's a bit for the intro. Let's talk about framework-defined infrastructure. I love this slide. All right. So Werner Vogels, CTO for Vercel, basically my colleague, right? Anyway, Werner gave this talk at, I think, reInvent, and he had this slide up there, primitives not framework. Now, again, we're talking about framework-defined infrastructure, so how is it related to that slide? You got me basically telling you, it's time to actually think about frameworks, not primitives. And I'll tell you why, and I'll also tell you when that might not be super appropriate. But let's take a slight step back here, right? And look at how we used to deploy infrastructure, right? So in the 90s, and I definitely was around, we SSH into machines, or worse, right? I'm definitely the FTP generation, right? It was rough out there. And obviously that didn't quite work, so we started doing semi-automated deployments. That can be anything from basically a bash script to something slightly more sophisticated, right? And I think that relatively naturally then evolved over to infrastructure as code, where you were like formalizing how you express infrastructure and then automatically deploy it. And today I'll talk about framework-defined infrastructure as a bit of an evolution. And it is actually related to something slightly different, which is called infrastructure from code. And I'll talk about in this talk how these are related but also different. Cool. So why do we care about framework-defined infrastructure? It provides us portability between different target infrastructure providers, so no lock-in. I'll talk about that. It eliminates the need to manually configure infrastructure to run application production, which is nice. Which also means I have now more time to write product code instead of doing system management. Really important is I can use my favorite frameworks, local development tools, unchanged. Right? I don't have to figure out how to run my sophisticated setup on my local machine. And because there's this indirection to how infrastructure is defined, we can actually only use the stuff that the security team okayed, right? So that's great. All right. I use that word infrastructure a lot. Probably everyone knows what I'm talking about, but let's make sure we define it. It's network equipment and setups, web application servers, databases, metrics queues. This obviously is not a complete list. That's not what it meant to be, right? It's the stuff that you have in a data center, etc. And we have to deploy it. I think what's slightly more complicated of a question is the question of what is a framework? And the way I think about it, at the core of the answer to that question, right, lies the Hollywood principle. And the Hollywood principle is, don't call us, we'll call you, right? And that really kind of summarizes how a framework is different from a library. In a library, you kind of call the library, right? It has a function. It's a nice function. You call it, right? In a framework, you go and write code to a pattern that the framework then invokes while it is managing a life cycle, right? Which is very, very powerful. That can be imperative, where you like pass a callback, or which is really popular today, and certainly in Next.js where we make, it's how it works is where you have files that are in certain places, and these files can export functions and they get called, right? There's many, many ways to do it, but the common pattern is that the framework calls you, right? The framework controls the life cycle of the system. And that led me to this interesting observation that frameworks are really solving the halting problem. Not in general, obviously not, right? But what they do is they allow us to understand what a program is going to do, right? I can't in general look at a program and understand what it's going to do, but if I know it complies with the framework, and I understand the framework's flow and life cycle, then I can actually understand whether this program will halt. Cool. That forms the basis for what then will enable us to do framework-defined infrastructure, FdI. The way it works is that you write code in a framework dialect. And what I mean with a dialect is that it might be Go, it might be C++, it might be TypeScript, right? You still use TypeScript. There's no different necessarily like DSL kind of specialized language, right? That's not what I mean, right? What I mean is that you comply with the words that the framework gives you, right? That's really why it's a dialect. That structure that comes from that dialogue, we take that in our framework-defined infrastructure compiler and compile your program into the infrastructure as code definition. Once again, so that's kind of coming back to Versal's platform. We support a bunch of frameworks, I think overall 35. And so we have a compiler per framework where we look at the code written to the framework and then we map it to the kind of infrastructure primitive that we can deploy to. Now, because not everyone's a front-end expert, I want to really quickly talk about kind of the anatomy of a modern front-end framework, right? There's many of them. I already mentioned we're supporting 35, but they have certain things in common, right? That kind of is really important. And because I want to use some examples in this talk, I wanted to bring everyone up to speed what these kind of things are that you'll find in the modern framework, so you can abstract a little bit and follow along, even if you're not a front-end expert. They almost all kind of provide something called isomorphic rendering, which is the ability to write some code and run it on the server and on the client without really changing too much what you do based on the environment. There's always some kind of routing, which is in general something that frameworks do, right? Where you have some kind of request and you map it to some function or like functionality you want to run. And so that's kind of a core framework function, because here you have like the request and then the framework calls you and it figures out what's going on in the middle. That's routing. There's things like pages and API routes. Pages in the front-end framework are like things that users see. API routes are like routes that get invoked indirectly by other machines. We often have something like middleware, where we can write code that lives in that routing space, right? That changes how routing works. There's clearly data fetching and caching and stuff like asset optimization, something you would find in the front-end framework, very specific to front-end because you surf images and stuff like that. Cool. So with that basis, let's look at an example. So this is on the left, you have some files that you'll find in a typical Next.js application. And let's go through that, right? So the first one up top under your code, there's pages/index.tsx, and it has a function called getServerSideProps. Now I'll go into a little bit of detail, but what that means when that function is present, again, this is the dialect of the framework. What it means is that every time that page gets invoked, I have to run some compute. And that is why our compiler provisions a serverless function to actually execute that compute. Let's go one down, pages slash block.tsx. This one has a get static props method. Again, in the dialect of Next.js, pages router, what that means is that this page can be rendered at build time. Now that means we will then do that at build time, and all we have to deploy in production to serve that page is a static file. And that's why it goes onto the high performance static file service. Next one, that's just an image file. All right, cool. Goes out to the high performance static file service. Next file is middleware.ts. Now that's a bit of a different beast. That runs a routing phase that needs to run globally, right? So we deploy a global edge worker to perform that task. And then finally, we have a JPEG image. Now, we could serve that with a high-performance static file service, but for larger images, it makes sense to do image optimization. And so we deploy an image optimization service to help you serve that image in perfect quality. Now, all of this knowledge, how this file maps to this service, how this file needs to go there, has to be somehow routed, right? And so that's why we take apart that application, deploy it, and that's the very right, to our application routing table, which then allows our gateway service that takes all the ingress traffic to our service and allows it to route and then go to the correct infrastructure for that customer. Cool. Let's look at this in a little bit more detail and also kind of look at the life cycle here, okay? So coming back to this blog post example, right? You can almost ignore that first export default function. That's just the code that actually renders a blog post. We don't really care about that in this example, right? So we have this file and we have this export, and I already mentioned this get server-side props. Again, we don't really care about the contents here. That method present means that we need to deploy that serverless function. Okay, we push it, Vercel deploys the serverless function. Great. Next up, I'm going to go to my text editor and make a change. It's a bit hard to see. Get server-side props, let's change it to get static props. Again, this is a change of the source code. We saw that in the previous diagram that if you have get static props, we can actually render it at build time and deploy it to production as a static file, right? So just the code changed, you redeploy, and the infrastructure that is needed for this page changes, and Vercel will just do that for you. Now, a final change, and it's a little bit more subtle, I apologize. I'm adding this one line here, revalidate 60, and I'm going back and going forward, revalidate 60. Now, what this means is that every 60 seconds with traffic, this page will be re-rendered. But outside of those re-renderings, we serve a static file. So we need to deploy both the static file plus the ability to re-render the page, so we need another serverless function, plus the ability to in the background perform the invocation against that serverless function and then write it to our static file serving system, right? Again, one line of code and a whole bunch of orchestration now has to happen. But that all comes from the FdI compiler understanding what you do. And just to kind of complete the example, finally, we get the middleware, right? And again, there's just a file that's in my project, but it leads to the global provisioning of the edge worker that can actually perform this work. And I promised this early on in the presentation. Eventually, you deploy to Vercel, and we give you this deployment summary. Now, again, you get this every time you push any change to your Git provider, and we will then determine the infrastructure that you need and tell you what we deployed, right? But because you didn't tell us, you only gave us your program, right? And then we compiled your program to this infrastructure. Awesome. Now, I want to pivot a bit. So this is the basic of FdI. This is how it works. I want to now look at various aspects of it. The first one that I think is really key for FdI really differentiates itself from other way of doing things is that it's different in terms of vendor lock-in. And, I want to be very open about this. Vercel, we're very broadly speaking a platform as a service company, and they have a reputation of having vendor lock-in. But let's look at where it actually comes from, right? So I'm going to walk through a few files, right? So this is Terraform. I'm not a fan of Terraform. Clearly, my editor doesn't even have syntax highlighting. I didn't use it all that much, but that's okay. We can all read Terraform, right? Anyway, what I really wanted to point out is this is a Terraform to deploy a Lambda function, right? So in Vercel, all we did was like look at your file and we deployed a serverless function, but you didn't say you want a Lambda or Google Cloud Run, right? Here in this Terraform file, you very clearly say what you want, right? So you're now locked into AWS because you can't just deploy this to Google, right? Because Google doesn't have Lambda, right? So you're directly connecting yourself to your deployment target. You know, this is another vendor. I don't want to like talk bad about them, but they have a CLI, right? It's called Wrangler. You want to deploy their stuff, you need to use their CLI, so you're locking yourself in, right? I haven't changed the name of the vendor here. They have this TOML file, right? They invented some syntax to define headers. Sure, seems fine. But again, you're locking yourself to the vendor because you're writing code to their conventions, right? And that's just not how Vercel works, right? And that's not how FdI works. There's this customer, very large customer of ours, and they shared their source code with me, which obviously you don't have to do, right? But they did. And so I was looking at their entire large applications to see if they, did anything Vercel specific. And lo and behold, the only mention of even Vercel in their entire 100,000 plus line code base was that they git ignored this like build artifact that we make when you deploy, right? So this entire application that is very, very sophisticated and makes literally $1 billion a year or more, right? This application gets deployed to our service and has no idea that's what it does, right? I mean, it has that git ignore file, but I mean, that's really nothing, right? So it's all fully automatic. And all you do is write code to the conventions of whatever framework you pick. Cool. So this is actually also really important for my next point, right? Which is the local development experience with FdI. Now, if you've ever tried to like go and deploy, anything with a sophisticated cloud setup, right? You probably have something like Docker Compose situation, like running Lambda locally is incredibly difficult, right? But on the other hand, you're probably using a framework, and if you look at your framework, it usually comes with some instructions for how to run it locally, right? And the framework is really incentivized to really help you to make that a good experience, right? And our experience is they are really good at it, right? Like we make a framework and we invest so much time in making local development experience good. So Vercel does not have a local development experience, right? You just use whatever your framework tells you to do, right? You run the command that were in the like getting started page, and that's all you have to do, right? And so you get the perfect, best in class development experience locally. Cool. The next thing I want to mention is the notion of immutable deployment. I already mentioned that, on Vercel, whenever you push, we deploy for that kind of, for that event, right? Like you committed a git SHA and we give you an infrastructure for it, right? So let's look at an example. You make a git commit, whatever, ABC123, right? You deploy that git commit and we give you a virtual infrastructure for that git commit, right? Remember back how I changed get server-side props to get static props, and that change to my program changed the infrastructure that I needed, right? So let's imagine I commit that change, I deploy it. You don't want to change the old infrastructure because, everyone's kind of committing code, right? That's not how it works, right? So instead, what we do is we give you a virtual infrastructure for every single git commit, right? And so obviously there's some deduping with content addressing, but from a developer point of view, every single time you get a completely new infra. There's many ways why this is amazing, right? So one of our most popular features is instant rollback. And because when you deploy to production, the last production deployment is still there. If you realize, oh my God, I have a bug, you can just go back. And not just 1, 2, 3, 4. Like you can go back as far as you decide, really, right? We don't actively do deployments unless you set up a policy for that. It also means, again, like instant rollback is called instant rollback because it doesn't really it doesn't do like key 8, rollback and then kind of does a bunch of stuff, right? Really, all that's happening is that you have these immutable deployments, and when you say mydomain.com now points to the other deployment, all that's happening is that a message goes out globally to our serving stack saying serve this other deployment, right? So it's effectively a bit flip compared to the traditional way of doing this. And maybe as a bit of bonus content, that enables something that I don't want to dive like too deep into, but which is very powerful, that we call Skew Protection, where we actually allow clients to force the server to run at the same version so that you don't have to worry about the problem that the server might have changed under you and now communicates in a different fashion from what you expected, right? So again, that's possible because we can actually serve different deployments, effectively infinite deployments at the same time. Cool. And, I think this is a interesting topic. I think what it does bring up is kind of whether FdI depends on serverless, because I called it virtual infrastructure. That really only works if you have some notion of serverless infrastructure, right? Because if you actually have a computer and you need it for every deployment, and every git commit makes a deployment, then you really quickly run out of computers, right? So you need some notion of something that's serverless, and in particular something that scales to 0, right? So that if you have, in theory, that old deployment, but it gets no traffic, it doesn't take more resources than whatever the storage cost that actually has the data, right? Which shouldn't be all that much. Cool. So yeah, we kind of need serverless, but if you're really determined, you could probably make it work without. Next question. Does it work for stateful workloads? So what I mean with that would be like a database, right? I would say it's definitely much harder, but it's not impossible. So what it really means is that you need some way of provisioning infra lazily when usage is discovered, right? Like say you connect to a database, okay, then we make one, right? You need some way of isolating changes to their branch, right? So in Rails, there were like these database migration scripts, which I think are best practices nowadays. But if they operate on your core database, then you don't want to run them on a branch or for every commit, right? So obviously most databases don't have this, right? You have like an instance here, an instance there. But I think what we are seeing is that there's a trend of even stateful workloads kind of coming towards FdI. So what, for example, we are seeing is a provider like Neon, which is a Postgres provider, and they support copy on write branching of your database. So they can actually give you a copy at very little cost every time you deploy, and really bring you closer to the FdI vision, even for a stateful workload. Now, having said that, there's definitely trade-offs that I want to acknowledge, right? Especially if you're a DevOps person, it can feel a little bit off that you don't really know what's going on in production, right? Like because it kind of comes from the code, so you have to deploy to find out, right? But again, like we tell you when we deploy exactly what we did, right? But it's not like there's not this Terraform file we can just look. This is what's going to happen, right? So there's definitely this indirection. As I was mentioning, especially with stateful workloads, this can be a bit of a leaky abstraction. Like if you have only one, then it can't map to this like range of deployments, right? And you're really, in your observability strategy, you have to account for this ephemerality of resources, right? That you can't do a top-down kind of observability tree because things are kind of bubbling up, bottoms up, and so you have to kind of account for that. It's manageable, but I want to acknowledge that's a thing. Cool. then because there's this like continuum of space, right? So the original infrastructure as code was really typically a declarative thing, right? Where you wrote down, this is the infrastructure that I want. Maybe you actually wrote imperative code, but you kind of said what you wanted, right? So there's this kind of advancement. I don't want to, it's not maybe not the right word, right? Like, so there is this, there's infrastructure from code as a evolution, certainly of infrastructure as code, where you write code that actually does business logic, but you're using a specific SDK that is bound to the infrastructure. So it's very tightly bound to the infrastructure, right? And that is very related to FdI because you're writing business logic code, right? But it doesn't have this extra level of indirection where you really are not thinking about infrastructure. You're really thinking about your framework, and the compiler takes the logic out of the framework to make things work. But again, like this is definitely a continuum, and these terms are related. Yeah, I mean, there's a bunch of examples outside of Vercel. I think Google's Service Weaver is really interesting technology in a very different scope, right? They're thinking about how to deploy serverless services in like a microservice architecture. I think Dino KV is actually a really interesting example. They have this KV that works locally, works in production, and is really seamless in the deployment flow. And then there's stuff like Encore.dev, Nitric Framework, and they're definitely on that continuum from like, it's more like infrastructure from code, somewhere in between. But these are all worth checking out. All right, so with that, hopefully I convinced you that it's worth paying attention to frameworks and not only thinking about directly programming the primitives. Just to bring it back for everyone, it's about portability between different target infrastructure providers. We want to eliminate the need to manually configure infrastructure to run an application in production. We want to increase the time spent writing product code, right, over system management. We want to just use whatever our framework gives you for local development. And finally, as a security team, we want to know what's going on in production. And so we love it that there's a system that just only allows folks to do what actually the system does, and doesn't have an easy way of bypassing it and folks deploying whatever they want to production. All right, that's all I had today. Thank you very much. Again, my name is Malte. You can find me on the internet, and thank you very much.